Good morning or good afternoon, doctor. My name is Chua Yi-Xin. Today, I will be presenting on the application of first-order RC circuits in ECG signal conditioning. An electrode diagram, or ECG, is used to record the electrical activity of the heart. It is commonly used to monitor heart rate and detect cardiac abnormalities. ECG signals are very small in amplitude and low in frequency, which makes them easily affected by noise. So, in real clinical environments, ECG signals are often corrupted by noise, and this includes a baseline wonder caused by breathing, muscle noise from the body movement, and also the electrical interference. Therefore, raw ECG signals are not suitable for diagnosis and must be filtered. So, now I'm going to talk about the role of first-order circuits in ECG. First-order RC circuits consist of one resistor and one capacitor, and due to their simplicity, they are widely used in biomedical devices such as ECG. In ECG systems, they function as high-pass and low-pass filters for signal conditioning. And for high-pass RC filter, is used to remove baseline in ECG signals. It attenuates a very low frequency components while allowing useful ECG signal to pass. The typical cut-off frequency for this filter is around 0.05 Hz, and the formula is shown in the presentation slides. While low-pass RC filter in ECG is to remove high-frequency noise, it helps reduce muscle and electrical interference while preserving important ECG features such as the P wave, QRS complex, and T wave, and the typical cut-off frequency is about 100 Hz. And here is the ECG signal conditioning block diagram. This block diagram shows a typical ECG signal conditioning system. The ECG signal is detected by electrodes and then amplified, then passed through a high-pass and low-pass RC filter. And this process produces a clean ECG signals suitable for analysis. And here is the sample calculation for the high-pass RC filter. Using the formula 1/2πRC and choosing suitable resistor and capacitor values, the calculated cut-off frequency is 0.048 Hz, which is approximately 0.05 Hz, and it meets the ECG requirement for baseline wonder removal. And then this graph shows the frequency response of a first-order high-pass RC filter. Frequencies below the cut-off frequency are attenuated, which remove the baseline drift, while high-frequency ECG components are preserved. Now I'm going to talk about the characteristic of a first-order system. A first-order circuit contains one energy storage element, which is the capacitor, and the behavior is characterized by the time constant RC, and the time constant determines how quickly the circuit responds and helps to prevent ECG waveform distortion. And the advantages of using first-order circuits, which are first-order RC circuits are simple, reliable, and cost-effective, and they consume low power and suitable for the low-frequency nature of ECG signals. Therefore, first-order RC circuits are widely used in medical devices. In conclusion, ECG signals are weak and easily affected by noise. First-order RC filters play an important role in ECG signal conditioning by removing unwanted noise. Their simplicity and effectiveness make them essential in biomedical ECG systems. And that's all from me. Thank you so much.